Okay, so now we are going to discuss in the more details on the system of linear algebra. Okay, so basically we start from definition of linear. Okay, linear, I think easy to follow, that whatever, for example, if any ax plus by equals c, where the a, b, c, they are a real number, so we say that this will be a linear equation, right? And I think in your study before, there are several ways to solve the linear equations, right? Including substitutions, eliminations, right? And something like that. We are going to see how we can solve the linear equations within the matrix form, okay? Or we can write, more general is a1 x1 plus a2 x2 plus dot 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 plus an xn equal bn, where all the a1, a2, an, and bn are real numbers. Okay. And all the x1 until xn, they are the variables. So we are going to study if we have more than one linear equations. We call the system of linear equation or linear systems, which we are having our form here. So this is called the system of let's say linear equations, or we can say it's linear systems. All right, so basically it's the same thing. So x1, x2, and until xn, there will be the variable. b1 is the constant. b1, b2 until bm, that will be constant. So a will be the coefficient. So a, right here, a, this will be coefficient. And then the number ij will determine, like in the matrix system, 1, 1 means row and column. Okay? Row 1, column 1. Okay? This means row 2, column 1. So we are building or stack up our linear equations as a system like in the matrix. But we are not there yet, but we are going to. Okay, in our system, we are going to make them as in matrix. But we are still having our variables here, x1, x2 until xn. And we have b1, b2, bn, which is the constant. Okay. So all the number in the coefficient, it will be denoted the row and column. And then if the this is the constant, is called the constant. If the constant, so if the constant equals 0, okay, we can say the system is homogeneous. Okay. Or if not, then it will be non-homogeneous. For example, let me write on the right side here so that you can still can see. If I have 5x1 minus x2 plus 3x3 equals 0, and then x1 minus 3x2, let's say this is equal 0, and then maybe 3x1 plus 6x2 minus x3, this will be homogeneous. This is the homogeneous system. Okay? Our system is homogeneous. Okay. Okay, so that's how we built this system. Okay. So if the system have a constant that is not 0, then it will be non-homogeneous. Okay. Now let me put this graph going here. Let me write something first. So of course, if we are discussing about the system of linear equation, then we are going to discuss how we build our solution. So solution, what is solution? So solution, let me just write simply, that is if or just satisfy each linear equation in the system. Or you can write completely solution. I think I will just add some words here, but this is already okay. I will just add solution is a set of numbers x1, x2, until how many variables we have that satisfy the equation. So basically, if we check some numbers that is satisfied, meaning the equation on the left equaling equation on the right, and that will be equal, then that will be a solution. And depends on how many variables we have, then that is how many solutions we are going to have. For example, we have 3 variables, so we need to have 3 solutions, okay? So let me write here. So if 3 variable, if we have 3 variables, means that we have 3 solutions. If we have 4, then 4 solution, 5 solution, and so on and so forth. And then there will be some category on the solution. Okay, so we say the solution could be consistent. This is one solution, or at least one solution. Okay, and then there is another one which we call inconsistent. This is no solution. For the consistent, it can be, let me write here, it can be unique solution, perfectly unique one solution, or it can be infinitely many solutions. Okay. Now to visualize what does it mean by inconsistent and inconsistent, or what is unique solutions or infinitely many solutions, we'll zoom out a little bit. You can see how it looks like here. If we have 2 equations in 2D system, okay, you have x, y. So you have two variables, x, y. Suppose that you have an equation that is this blue line and the red line. And where is the solution? The solution is perfectly, uniquely on these coordinates. Okay? Intersect these two equations, so the red and blue. Okay? If we look the consistent here, this is how, let me just write what is that. This is going to be this is a unique solution. This is unique solution. The middle one is the infinitely many solution. So the last one is no solution because there is no intersection. But how do we interpret the middle one? The middle one can be interpreted as, so you have a line, okay, you have an equation, you have another equation, but when you draw, it's the same. It's the same line that is going to, the same project with the first line. So no matter how you put your point, all points are correct. So that's how you interpret. That has infinitely many solutions. Okay. Compared to this, it's only exactly at this point. And if you see here, there is no way that these two lines will be in the cross section, right? So that's how we build the system. And we are going to see later on these three cases, how we are going to define through the system, through the, let's say, the matrix system that we are going to build. I think two dimension is, I think, easy to follow for the picture. But how about if we have 3 dimensions? So we are going to have a 3D space. Okay? At least 3 variables we can easily draw. Okay? But if we have more than 3, I think that will be a little bit difficult to draw and to imagine how it looks like in terms of visuals. Okay, I will go to the next page. Okay, so this is how we are going to see system on 3 equations, 3 variables. Okay, so you will see that the consistent one, it can be all have a plane on all axes. So z-axis, x-axis, y-axis, all has a plane, and of course, all will be intersect on this point. But we also have a consistent one, which is only the 2 plane, which have the line intersection. This is also the same. If we have this kind of condition, we have a line intersection. It means that if we take another variation of 2 planes, it will be the same line intersection. We mean the same, and the same with this. But this is having a stack like a rotating like that, and we have a perfectly line intersection. So this is all consistent. For inconsistent, we have also 3 variations that we can build. We have 3 different levels like this, which the plane never going to intersect with each other, right? Or here, there will be no intersection, okay, between the line, okay? And this is also the same, okay? So this is having 1, 2, 3, 1, 2. So it's also inconsistent. It's similar to infinitely many solutions. So it has more than one. It has more than one single line. Okay. Okay. There are several procedures to compute. Basically, what you can do. There are 3 operations. Okay? This is a word, but I think it will be better if we just do the computation. But let's just say number 1, you can multiply the equation with any non-zero constant. So you can multiply by 2, by 3, by half. You can multiply. You can interchange positions, which means, okay, I will move this to the middle and this to the top, or the third one to the top, okay, and this one to the middle. It's okay, you can change everything, and then add a non-zero multiple of one equation to any other equation. So you can add or subtract. Okay? So you can add, basically add, because subtract is just add and then multiply with the negative, right? So you can add this or add this to, okay? So 1 and 2 you can plus, 1 and 3 you can plus, okay? And basically that is the operations that we are going to work on, okay? So for example, here we have system of equations, 3 variables, okay? And then let's say we are going to exchange the variables or exchange the equation. So the first and the second I will change, so I will write so nothing happened, just changing the order. So I will change this order. So I will show you like one by one slowly how the process are going to work step by step, okay? And then this will be the last one. Okay, so if we want to remove, the x1, okay, we want to remove the x1 on the second row, on the second equation. What we can do is we can add, okay, So let's say to make it easy to follow, let me just write using, so okay, row 2 become row 1 and row 1 become row 2. Okay, and then I would like to R2 minus 2R1. Okay. Okay. So what I want to do is I will multiply the first one with 2, and then I will set the second row minus the first row multiplied. Okay. That will be the new second row. So first, still write again the first one, and the second one I will use this equation R2 minus 2R1. So, or let me just write with the different color. So this will be 2 minus 2x1, so 2x1 minus 2x1, so 0, let me just write 0. And then 6 minus 4, so it's plus, or let me just write 4. 6 minus 4 is 2, so 2x2. Okay. And then x3 minus 2. So 1 plus 2, so 3. And then 7 minus 2, so plus 2, so 9. Okay. The last one still the same. And then I would like you to follow up the third one with the same process with the previous one. So 5 x1 plus 7 x2 minus 4 x3. All this will be minus the first equation multiplied by 5. So let's multiply by 5. So the first one's still the same. So let me write here that the R, oh, should be blue, sorry. So this will be R3 minus 5R1. The first one's still the same, x1 plus 2, x2. And the second one will be 2x2 plus 3x3, and then equal 9. And then the third one, 5x1 minus 5x1, 0. 7 minus 2 multiplied by 5 is 10, so 7 minus 10 is negative 3. So negative 3, or let me write with the green to let you know we've done something here. And then what else? Negative 4. Negative 4 plus, or negative 4 minus 5. So 5 minus 4 is plus 1, so plus x3. And then 9 minus 5, so 9 plus 5 is 14. Okay, now we have the second row and the third row. The x1 is gone. Okay. And then we are going to add 1 and 2 by removing the x2. So I will change the row 1. Okay. So the first, let me write here. This is R1 minus R2. Oh, I think it will be confusing. This will be, let me just add. The new R2 is R2 minus 2R1. The new R3 is this. And this should be the new R1. If not, then you'll confuse which R1 and R2, which refers to. Okay. So I will write the first one, x1. 2x2 minus 2x2 is 0. Negative x3, negative 3x3 is negative 4x3. Let me give space here. Let me give space and then negative 4x3 equal negative 1, negative 9, it's negative 10. And then the second row, I will divide by 2, or I will multiply with half. So the new R2, here, I will write half R2. So this will be x2 plus 3 over 2 x3 equal 9 over 2. And then we have negative 3 x2 plus x3 equal 14. Okay. Now, I think we can solve these two. We can multiply by 3 and then add to remove the x2, and we get the x3. So basically, this is just one way to see how it's going to be processed. There will be many, many ways you can try to solve it, which actually there will be some suggestions which process you should do first. So let's say we are going to eliminate this. Okay. So I will write here that the new R3 will be composed of R2 or 3R2, sorry, 3R2 plus R3, which means that it means the new R3 that we will write here is coming from this process, okay? So we can write the first one still the same. And the second one is still the same. Just keep it as it is. And then the third one, we're going to plus these two. So 3x2 minus 3x2 is 0. And then 9 over 2 plus 2 over 2 is 11 over 2, x3. And then 27 over 2 plus 14. 14 is 28. 28 plus 27 is 55. So 55 over 2. Now, we could see that we could simplify it. Let me move here. Okay. Now we can simplify the last one, so we can write x1 it seems like a long process that is rigorous, but I will say that the next method that I will show you later, it will be really helpful for computation, especially if you want to learn more about the linear algebra. Now we have x3 is equal 5. Now we can use this number to substitute the x3 here, okay, which we can apply 15 over 2, which we can write here. This can be, let me just write one by one. And this will be x2 equal, it's supposed to be 9 over 2 minus 15 over 2 so 15 over 2 it's 6 over 2, so supposed to be negative 3. And lastly, oh, I think we can do the first one. I forgot. So substitute let me just write directly here. This will be, or let me just write all the process here. So negative 4, 5. This is x2 plus 3 over 2, 5. So x1 is 10. X2 is negative 3. X3 is 5. Okay. Now, of course, you might argue that you could do the same thing using your substitution or elimination process as you know from before. But writing down all the operations like this is helping you to navigate how well you know the operation, each cases. And it will, as long as you are able to compute without many mistakes, this will help you through navigate all the systems. Okay? Now this is what we call the operations, the elementary operations. Okay, the elementary operations, which is very basics for linear algebra. Okay? So basically, we can write the equations. We can change the order, and then when you write the new system and you want to make a process, you can simply write in the middle what is the process you want to make. Okay, what is the process? For example, the new R2 will be the previous system R2 minus 2R1. That will be our new R2. So R1 is still the same, and R2 will be the same. But I will write like one by one. But if you want, for example, this process here, you could combine with this, or this combined with this. So you could do two processes at a time. Or more, if you want. But to help you to avoid mistake, maybe one or two. Okay? If the number is easy, maybe you could do more. Okay? You could do like, for example, I would like to have the new R2 and the new R3 at the same time. It's okay. As long as you focus and consistent, it should be okay. But if you have problem with the numbers, then do one by one. Okay? It's okay. Do one by one. Now, of course, if you write x1 plus 2x2 minus x3, or maybe in another variable, x, y, z, blah, 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 y, z, okay? Maybe take times, right? Take times to write. So there's another way to write that the variables we can remove. So we could just focus on the numbers, okay? Which we call the augmented matrix, okay? The augmented matrix. Okay, so for example here, we could just write only the coefficient. How many row you have, you just write, and then this is the constant on the row. Okay? And as long as the system works, okay, you could have as many as you want. System of, maybe you have 7 equations. Of course, if you have 7 equations, you don't want to compute that one by one using substitution or eliminations, right? It will take time, and then you will lose focus. But if you have the system and then focus on one by one, then you could process that. Actually, you could process that. For example, if we have this, if we want to write the augmented matrix, we could write like on the right side here, 2, 6, 1, 1, 2, negative 1, 5, 7, negative 4, and then we have 7, negative 1, 9. So we have the augmented matrix or matrix of the system to easily compute the linear equation. What happens if, for example, there is no x1 here, so we could just put 0. We could just put 0. Okay. And then this is the same as before. You could multiply with any number as long as it's not 0. We could exchange or interchange any rows and then add these 2 rows or more into one another. As long as you consistent and you know how the process works, you can do all of that like we did previously, but we change only the numbers. And then we have what we call the elimination method. So elimination method in the matrix system is a little bit different. The difference is we are going to focus on the numbers. Okay? So we need to make one specific numbers, which is exactly 1 and 0, it appear in our system. That is how we eliminate the system. Okay. So our target is the third one here. So the row that is mostly 0, it will be on the bottom of the matrix. We call this also in another terms is the row echelon form. And then we can reduce those row echelon form into this number 4. Number 4 means all entry is 1 and then the other part will be 0. Okay. We call that as the Gaussian elimination or Gauss-Jordan. Okay, so this will be, so if we have this is the Gauss-Jordan. And this will be the Gaussian elimination. These two is pretty similar. We are going to see the differences, I think, later on. Okay, I would like to continue this, but I think since we don't really have much time left, so I think this will be for Friday lecture. Okay. So basically, this one, I was just showing you the first process here that you could do the interchange the R1 to R2, which gives you 1 to -1. Okay. Or maybe I will just solving this and then continue next Friday so that we can have a new one. So this one, I want to make the second row as 0. So the new row will consist -2 R1 plus R2. And then I would like to third row to have another 0. So this will be 1 to -1. So 2, so -2 plus 2 is 0. -4 plus 6 is 2. So plus 2 plus 1 is 3. And then this will be 9. And the third row, -5 plus 5 is 0. -10 plus 7 is -3. And then plus 5 minus 4 is 1. And it is the same, I think the same number as previous case. But if you notice, we have now 0 here. So our goal is at least to make this part all 0, 0, 0, 0. And by